we're gonna wait 5 minutes and then we're gonna start. Welcome everybody to today's webinar about how to achieve net zero carbon for offices. My name is Rossella Perniola. I'm a mechanical engineer and I work at Scotch Partners. I'm the current chair at CIBSE YPG, which is a collective of young engineers focusing on energy performance. Our mission is to improve the energy performance of buildings and reduce their carbon footprint, to reach out the young professionals and those aspiring to join the industry, supporting them in their professional development, and to provide a forum for discussion, enabling networking opportunities and promoting collaboration amongst members. Our events include seminars, building tours, and pub quizzes. With the lockdown this year, we are exploring some further activities. So if you want to know more about us, you can follow us on LinkedIn and Twitter, as well as on Eventbrite and the CIBSE website. Tonight's event is very special for us because it's probably the first time that all speakers are or have been part of YPG. Our liaison officer, Jennifer Elias, also involved with LETI, is going to talk about modeling to achieve the targets within the LETI Climate Emergency Design Guide. Our secretary, Oliver Lockhart, is going to focus on the role of data in achieving net zero carbon. And our former liaison officer, Kasha Mohammadian, is going to touch base on net zero pathways for existing buildings. As these topics are very much interlinked, the speakers are going to alternate their presentations in 2 rounds of circa 5 minutes each. Before handing over to Jen, I just would like to let you know that this webinar is being recorded and the record is going to be uploaded on the CIBSE YouTube channel. The slides are going to be ready shortly on the CIBSE website. And if you can like the questions that you would like to be addressed first in the chat box, we're going to do the Q&A session at the end. So let's just see when Jen is ready. Over to you, Jen. Jen, maybe you're on mute.
So thanks everyone, good evening. So this evening I'm going to talk a little bit about the LETI Climate Emergency Design Guide and focusing in on the commercial offices section of that document. So if you haven't downloaded the document, you can access it via the web link on the right hand side of the page there. But fundamentally tonight, even though that design guide is more than 100 pages, we'll be focusing in on the commercial offices, operational energy section only. And I'm going to provide a bit of an overview of what the sort of modelling went into to develop the EUI target that we've identified there. So to start with a bit of background about what is net zero. So fundamentally net zero or net zero carbon economy is when all of the energy used in the UK is provided by renewable energy. So at the moment, where on the left-hand side, we use more energy than we can supply with renewable energy generated within the UK or its waters. We need to move to an economy where all of our energy demand is met 100% by renewable energy. This chart taken from the UK Green Building Council demonstrates what we need to do to get there. So this orange line here is the renewable energy supply in the UK. You can see that we really need to increase this. However, reviewing base projections for the amount of renewable energy capacity available to us in 2050 shows a pretty stark picture that actually we need to also reduce our energy consumption. Buying a green tariff isn't enough because the energy that you're using on your green tariff is coming from someone else's share, who has to then use gas power generation to compensate for it. So we're looking to do 2 things with our targets. The first is increase renewable supply, but at the same time reduce operational energy demand. And that's what the energy use intensity targets aim to identify. The Royal Institute of British Architects, the RIBA, have identified a number of energy use intensity targets to meet this demand, as have the UK Green Building Council. And the key thing here to realise is that there's a huge amount of industry consensus around what these operational energy intensity targets need to be. On this chart here, I've compared the LETI target, 55 kilowatt hours per metre squared gross internal area per year, to the UK Green Building Council target, that's 55 kilowatt hours per metre squared gross internal area, or 70 kilowatt hours per metre squared net internal area, and the RIBA target on the right-hand side there, which is 0 to 55 kilowatt hours per metre squared gross internal area per year. So, if you walk out of this webinar knowing nothing else, know that 55 equals 70. These targets only differ in the area metric that's used to normalise the result. So how do we arrive at these targets? Fundamentally, what we've done is taken the Bayes projection for how much renewable energy is available in the UK in 2050, and then divided that down by the energy use of all the different sectors of the economy, agriculture or in manufacturing, buildings obviously, and then divided that by the floor area of each of the different building types to arrive at an energy use intensity target for example, commercial offices. At the same time, we've done a bottom-up modelling process, and that's what I'm going to talk a little bit more about in just a second. And that bottom-up modelling process says, okay, we know what we do and how we design buildings at the moment. What do we need to change to reduce our energy use within buildings to hit that energy use intensity target? So doing that bottom-up modelling relied on a relatively detailed process following the design for performance and TM54 methodologies with a full HVAC simulation. These are some shots from the modelling that we used. The key message here though is that these are not regulated energy targets. It's not a Part L model. It is a full TM54 design for performance model showing both regulated and unregulated energy uses. So what does that mean? This here is design for performance, a typical build, a new build design for performance simulation for an office. The energy use intensity target that we need to hit, 70 kilowatt hours per metre squared net internal area, requires a huge amount of reduction in energy use. And then that's distributed across the energy use intensities that you can see there. The Climate Emergency Design Guide goes into a lot of detail about what we have to do to get there. This is an excerpt from that guide. And you can see how important it is, the first step, reducing internal gains. Now that's obviously a double benefit, because if your tenant's using less energy, that's less carbon emissions, but at the same time, you've got a lower demand on your air conditioning systems. So within the model, we looked at what is a realistic small power target for offices. And this is again data driven, looking at using data from operational offices that we have, that we can identify 8 watts per metre squared is actually achievable in offices in London now. We've applied that to 90% of the floor area operating during sort of 8 AM till 6 PM standard time. And then an extended operating period for those 10% of floor area offices that tend to run a little bit longer hours as well. The same thing with people. And again, this is data driven in the sense that we have data from occupancy sensors, from access control card systems that show when people tend to be in offices. How does that compare to the standard design guides that we use? Well, if we compare that to the British Council of Officers Guide to Specification 2019, you can see that they look substantially lower than what we are currently designing mechanical systems for in offices today. The reason behind that? Firstly, we're looking to the future, where there is a reduction in screen energy usage, more efficient screens, more usage of laptops, reduced power consumption in that sense. We've also factored in diversity within the office. We know that 20%, 30% of people are not in the office every single day, whether they're sick or on annual leave. And it's by taking this realistic analysis of internal gains that we can really deliver some key energy savings. So at this point, I'll hand over to Ollie to talk more about how this data is gathered, where this data comes from, and what key things we need to look at when we're gathering data and collecting data for building performance analysis, and the importance of data in doing this modelling. So over to you, Ollie.
Okay, so I think you can all see me now. I'll trust you can. So my name's Ollie. I work for Hawley as a performance engineer. I'm going to give you at least what my take is on how data is going to be important as we drive towards net zero. And I thought maybe a good place to start would be with a quote from Matt Hastings from Innovate UK. So I'll give you a second just to read that on the screen there. And so I think that is pretty much spot on. So in my mind, data plays a key role in our drive towards net zero, especially within the built environment, for two main reasons. And firstly, it allows us to check that we're on track, to check that our buildings are performing well. And secondly, it allows us to ensure that we're learning from our previous projects and we're continually bettering our designs. So before we dive in, I just wanted to introduce you to this. So this is a study done by the Better Buildings Partnership, looking into EPCs versus actual measured energy consumption of buildings. So an EPC, for those of you who aren't familiar, is essentially a measure of how efficiently designed a building is, with an A being the most efficient and a G being the least efficient. And what the Better Buildings Partnership study suggests is that seemingly regardless of how efficiently buildings are designed, they all seem to perform the same. And so this, in essence, is the performance gap. And this performance gap is one of the things that really undermines our ambitions to try and move towards net zero. And what I find quite interesting about this is that this sort of data isn't really that widely available. I mean, how can we begin to close the performance gap if we're not even really monitoring it? And so that is where this comes in. So I'm sure you all are familiar with the higher energy hierarchy. So be lean, use energy efficiently; be clean, supply energy efficiently; be green, maximize the use of on-site renewables where possible. And then the fourth stage to the energy hierarchy is be seen. So monitor and declare actual energy usage. And the London Plan draft proposal actually sets out the be seen requirement for all major developments within London to monitor and report on their actual operational energy performance. And for me, that's key with regards to driving towards net zero, because it allows us to do a few different things. It allows us to assess our progress. It allows us to improve our benchmarking and our targets for new buildings. It allows us to demonstrate what's possible. And I guess most importantly, perhaps, is it allows us to speed up change in the sector by sharing what works and what doesn't. And declaring energy consumption, it works. It has a proven track record. So in Australia, Neighbours, and I'm not going to go into any detail on it, but Neighbours has driven year-on-year energy efficiency improvements since it was introduced. And declaring energy consumption is a key step in that process. Now, it's not the only step, but it's certainly a key one. And on a more local, on a slightly smaller scale, Cash is about to show you some examples of how monitoring energy consumption has helped him to improve building performance year on year for some of the projects that he's been involved in. But data alone, data on its own, is largely meaningless. It's the context that turns this data into useful information. So this on your screen here is an extract of data from the Display Energy Certificate database. So it shows the total energy consumption for all the offices in the database for 2019, ordered by their total consumption. But this doesn't really tell you very much at all. It tells you that some buildings use a lot of energy. It tells you that some buildings don't use very much at all. And if you were going to look at this data, you might think, for example, that the Welsh Government building highlighted there isn't performing well just because it's consuming loads of energy. Now, this here is the exact same data set But instead of being ordered by total energy consumption, it's now ordered by total energy consumption per meter squared. And this extra bit of information, this extra bit of context, already makes this data much more useful and usable, I guess. So where before the Welsh Government building appeared to be one of the worst performing buildings, it now actually appears to be one of the best performing. So context is key. It's really, really important, but this isn't the whole picture. We need to consider what other information might be useful to help us normalize this data. So in that example, there was still no information about the head count in the building. There was still no information about the occupancy profile. Was it a 24/7 building? Was it occupied 9 to 5? It doesn't tell you anything about the weather. Is the building mechanically ventilated, mechanically cooled, all that sort of stuff. So it's layering in all this extra context that allows us to turn this data into information that's much more interesting, but ultimately much more useful to us. And just one final quick note before I hand over to Kasia. One of the keys to achieving net zero is going to be having a very clearly defined metering strategy that identifies what data you want, what data you need, and how you're going to be able to recover that data consistently and reliably so that we can check that we're on track and ultimately check that our buildings are performing as expected. So I am now going to hand you over to Kasia, who I believe is going to talk a bit about how the current building stock in the UK is performing.
Thank you, Ollie. Okay. I wonder if you can see my screen now. A little thumbs up if you can. Perfect. Okay, perfect. Yeah, so my name is Kasia Mohammedian, and I'm going to be telling you a little bit about the challenges and opportunities we've been seeing in the existing buildings. So this slide here is, it's not moving. Apologies. Okay. So, yes, here we go. So this slide here is a graph. This graph here is data from CREM and GRESB. So CREM is Carbon Risk Real Estate Monitor, which is an EU-funded project, which is telling us where we are today and the scale of the challenge ahead of us for existing buildings, where we need to be in 2050 for different sectors of the built environment. And as time goes by, how the risk levels increase for portfolio owners, for asset owners, and for funds. So one of the, well, we all try to do the right thing for the environment, but one of the difficult conversations sometimes is the funding aspects and the financial side of things. Now, looking at data like this and thinking about the penalties that carbon tax that will be applied to buildings that are unable to perform to those sort of levels, a change in mindsets can happen. And what we need to do as consultants is to help our clients understand these risks that will show themselves in the future and help them see them in the current in today. This graph here is showing us the wide spectrum of building performance in offices, in both the air-conditioned offices and non-AC offices. And as you can see, the differences are quite huge. So you've got down the bottom here, buildings that are operating very efficiently, and at the top here, buildings that are not doing so great. And the challenge we have is to help all of these buildings, the better performing ones and those right at the end of the list to hit this 70 kilowatt hour benchmark that Jen was just talking about. So the key thing for us is to make the most of the refurbishment cycles ahead of us. We only have 25 years ahead of us to 2050, well, 30 years really. And we don't have time to make any mistakes. So there is no point in rushing to get all the answers today when we know that budget is limited, we have the embodied carbon implications and so many other factors. So it's best to think our solutions through, trial them on some pilot projects, make sure they work before mass rollout across portfolios. Certainly the discussion point around like-for-like replacements is no longer the case. We shouldn't really be seeing any more gas boilers being replaced for gas boilers with all the changes and the whole environment and landscape changing. I already touched on the embodied carbon implications and good metering and optimization. So Ali has already mentioned about the importance of metering and how it impacts on tackling the performance gap. To add to that, when we use data from existing buildings and run optimization programs, we are able to bring down the building load down to the minimum. And this enables us to create benchmarks that we can then use to redesign the building in a way that feeds the needs of occupants and the building itself. So a very much tailor-made solution for that building in particular, instead of relying on data that may be over-designed, plant operation that may be a result of an existing over-designed building, and lots of energy wastage. And the net zero roadmaps that we propose need to take into account the refurbishment cycle so that we can use the full power and the full financial instruments available to us to push through with our net zero agenda. So yeah, taking all of that in, what can we do today? So today we don't have all the answers. We have part of the answers, and we also know some of the unknowns that need to be addressed, hopefully in the near future. But something we certainly can do today about a lot of buildings that are performing very poorly, such as this building when we started our smart optimization program back in 2017, which was at around about 300 kilowatt hours per meter squared, quite an energy intensive office building in central London. Over the course of three and a half years, we managed to trim down the energy consumption by about 20% on this building. And what is interesting is that this building has, first of all, not reached its optimum state, so the journey continues. But also, there are so many of these buildings out there. So if we continue to do this on all of those buildings, we can already achieve a lot of savings which are not CapEx funded. These are only making the most of what is already out there and making sure it's fine-tuned to suit how the users use their building. How do we do this? So again, data is a key thing here. We pull out a lot of data from the building management system. We overlay it with different parameters that we either take from the BMS or from IoT devices that give us information such as occupancy data, CO2 levels, and so on. And by looking at things together, we get a much better understanding of how the building is performing in relation to the people inside the building and how they are using the space. And as you can see here, this is a very basic example. So we noticed one of the very first things we noticed with that building was that the air handling units were running 24/7, and they were not looking at time schedules or building occupancy. Another thing that is very important in all of this is how existing buildings can be the feedback loop to the new designs that are going to produce net zero buildings. So for the very first time, one of our very ambitious clients asked us to collaborate with their design team who are designing a net zero building. And they asked us to look at some of the similar buildings they have in the same area with similar conditions, and tell them what the different plant sizes are, and what is the actual peak demand in use. And what we noticed there was that about 30%, in this particular example, the chillers are about 30% higher capacity than in the warmest days of the year. They have to supply cooling. And this is even before any optimization program happened. So before we started doing any work, we looked at this data. And we are going through this journey now with on this building, and I suspect this difference will increase to maybe something around 40 or 50% oversizing. So I'm going to hand back to Jen, who is going to tell us about data-driven design techniques in developing net zero buildings. Over to you, Jen. You're on mute, Jen.
Fantastic, thanks, Kasha. So if we pick up from there, I suppose there's a lot that we can do with existing buildings, but fundamentally, buildings are operating substantially higher than the 70 kilowatt hours per metre squared NIA per year in London. So what do we need to do about rethinking office design? So this is a little bit from the Electric Climate Emergency Design Guide about the way that we've re-looked at some of the mechanical systems and things like space temperature, thermal comfort. So we've identified relaxing set points as one energy saving option, along with reducing glazing areas, adding external shutters to facade glazing, and ensuring that all windows are openable. The key here, particularly in terms of reducing the glazing area and implementing external shutters into the building, ensures that our peak plant capacity is low enough that we can make sure that it operates efficiently throughout the year. And then we looked at changing office set points. So, you know, early 2000s, everyone's in the office in full suits. We're conditioning people to 22 degrees in summer because they've got full suits on. But look, as we come out of lockdown, and I mean, I know certainly my own clothing standards have relaxed, and I think that more broadly, we're going to continue to see changes in office attire led by tech companies, and really seeing the clothing levels in summer come down. So then what if we add a little bit of airspeed and increase the air temperature within the conditioning system to reduce energy? And this is what the Climate Emergency Design Guide posits. So if we can control to 26 degrees and then add a little bit of ceiling fan energy to ensure that we've got a 5% percentage dissatisfied, so a predicted mean vote of 0, that can really deliver some great energy savings. And the reason that this matters and the reason this is important is this chart here shows within the blue section, that's cooling plant energy efficiency ratio, or EER, for sort of each hour of the year within the simulation. And what we've done by being able to minimise our overall plant capacity, is ensure that our plant is still operating efficiently at low load and throughout the sort of the hotter seasons of the year where we are seeing this peak cooling demand. Through the middle here is where we've introduced external openings, operable windows, to really keep that sort of peak load down during the mid-season. And then moving on to then rethinking mechanical systems that we put into offices. How are we air conditioning offices? So within the modelling and simulation, we looked at two different system alternatives. So a variable air volume system on the left and a fan coil unit system on the right. Obviously, the variable air volume delivers a lower energy intensity, given its free cooling potential, low pumping energy, primary only, not secondary. It's easy to control system as well. However, to get an SFP of 1.2 watts per litre per second, that's going to require larger ducts or rethinking how that system delivers air. The alternative, obviously, fan coil unit system, much easier to reduce the SFP. It's common, it's well understood, but there's a lot more moving parts. So the risk in operation is that poor maintenance leads to stuck valves, which leads to phantom heating and cooling calls. However, within the model simulation result shows that either of these systems do perform along the lines of the net zero target. And then finally, really looking into the ancillary energy use within the building. A lot of these things are only 1% of energy, but when you've got 20 things that are only 1% of energy, you've got 20% of energy right there. And a lot of those things are things that end up having to be optimised within operation. So key things in terms of the future net zero spec for buildings, looking at reducing lift energy, ensuring that you've got a light car, light assembly, ensuring you've got no standby power and a power off feature, and providing stairs for occupants to use them rather than taking the lift. Reducing IT and server loads. So as we've moved more things onto the cloud, can we bring down the peak capacity of our server rooms below what we would typically expect within an office space? We've moved down to 0.5 watt per metre squared net internal area as a target, and looking to achieve that through improvements to switchgear and fundamentally a review of what the end use capacity is required in that building. Likewise with back of house power, really rationalising things like trace heating, diesel sump heater power, avoiding air curtains, redesigning entryways to preclude drafts without needing an enormous heater connected to an enormous fan, for instance. Looking to choose efficient CCTV and access systems and really getting into the heart and implementing those effective controls. But, and I'll hand over to Ollie at this point, because fundamentally this doesn't work if we have a performance gap within the operation of buildings. So performance gap really needs to hit zero if we're going to have any chance of delivering net zero buildings.
Okay, thanks, Jen. Give me a second and I will have my presentation up. Okay. All right, okay, so to carry on from Jen, I mean, one of the key steps towards with regards to driving towards net zero is closing off the feedback loop and ensuring that we continue to learn from our designs, our past designs, our current in operation buildings. And so once we've spent time in these buildings, learning what worked, learning what didn't, we need to think about how we're going to feed those lessons back into our design, into the design stage to ensure that we're continually improving. Because that's exactly how the RIBA plan of work is laid out. So you start with your brief, and then you work through the design and construction and into the operation of the building. And all of those lessons that you've learned along the way should really, in theory at least, form the starting point for your next projects. And so there are really sort of two main stages to the feedback process. And the first of those is to learn how the building is performing. And so for this, we can use data analysis, as Kasia has shown some examples of. We can conduct interviews with building occupants, we can carry out surveys, all that sort of stuff. And depending on what sort of information it is that you're after, I guess, defines what sort of methods it is that you want to use to gather that information. But first, we need to consider what sort of information you're going to need in order to determine how the building is performing. And it's key to align that data strategy with the modelling to ensure that we can validate the model and continually improve the design process. So as an example, you may want to understand how a heat pump is performing. And if that's the case, is monitoring just its electrical consumption enough, or should you also think about monitoring how much thermal energy it's producing so that you can determine its efficiency? You may also want to consider what other systems you can recover data from. So Jen has already touched on access control systems and how they might provide really good indications of occupancy. You may also want to even interface with something like the Met Office for live and predicted weather conditions. So there's a huge host of data sources out there that we can get access to, and we really should consider these as part of our data strategy. And finally, you need to consider the resolution of this data. So for some purposes, monthly data might be fine. But if you're trying to understand, for example, how much energy is being consumed within normal working hours versus outside of normal working hours, a high resolution is going to be more appropriate than monthly, so maybe half hourly. So considering what data you need and its resolution is key to ensuring that we can validate our designs and our buildings. And this is an example I really like because it's something that no one really, as far as I'm aware, ever considers. So this chart demonstrates the actual electricity generated by a solar panel array versus what was predicted. So the green outline is the predicted generation and the solid green bar is what was actually produced. So if you look at the period October to December, you can see there's a bit of a drop in the actual measured electrical production. And was this because of the weather? Was this because there was a fault on the system? Without suitable monitoring in place, you can't know. And in this instance, maybe that suitable monitoring would have been a solar intensity sensor had it been considered at the time. So it's key to think about what data you're going to need to validate the installed systems and to make sure that your data strategy defines how you're going to recover it. So this is another example of the kind of information we want to be recovering. So this is a chart that shows the cooling demand profile of a shopping centre in London. So it shows that for about 75% of the year, give or take, the cooling load was less than about 5 watts per metre squared, and it tapers off until the peak load measured of about 30. And what's interesting to me about this is that yellow line there is the installed capacity of the cooling system. And so do you think that a cooling system that is sized for that capacity is necessarily designed to operate efficiently at those low loads that the building is generally operating at, as that we've measured the building is generally operating at? So we have that data as well. So this is, again, actual measured metered data. So this chart shows how the efficiency of the cooling system changes as the daily building load changes. So you can see that as the building load reduces, so does the efficiency of the cooling system. And so what this shows is that the cooling system isn't operating efficiently at low loads because it wasn't designed to operate efficiently at low loads. It wasn't considered, the efficiency of the system wasn't considered at those low loads, even though that's how the building spends 75% of the year. So of course, it's important to size your systems to deal with the peak loads. But it is equally important to make sure that systems will work efficiently at the loads they're most likely to operate at. And these are the kind of lessons I think we need to be learning. And these are the kind of lessons we need to be feeding back into our design teams to ensure that this kind of information can be used to inform the design process. So once we've spent time in our buildings learning how they're performing, we need to think about feeding those lessons back into our future designs. And there's a few standard ways you can do this. You can host workshops, you can carry out design reviews, you can perhaps produce some lessons learned schedules, that sort of stuff. And for me, this is a really key step because it's this feedback that allows us to continually fine-tune our designs. and help us to close the performance gap and ultimately help us to drive towards net zero. And I think that that's a closing thought, I guess. I think as an industry, this is a step that we really don't do very well. I think as individual companies, we may have some good processes in place to feed those lessons back into designs. But as an industry, there aren't really currently any good mechanisms out there that I'm aware of, at least, that do this. And this is something that I think we really need to tackle in our drive towards net zero. So I'm going to hand over to Kasia now to close us out and to give us a bit more, give us some more examples of fine tuning and optimizing building performance.
Thank you, Ollie. Yes, so in the next couple of slides, I wanted to show you another angle of looking at data and things that may not necessarily be evident, but have certainly proven themselves to be incredibly useful. So when the pandemic started and lockdown happened, we carried out a few weeks into the lockdown, we carried out an exercise on a number of building portfolios that we manage to see whether these buildings were on track to reduce energy spent because the buildings were empty. And we noticed a very wide variation. So on average, they were consuming about 16% less than before lockdown. Those that were worst performing were only using 3% less, so pretty much no difference before and after lockdown. And those that were the best performing post-lockdown had actually been able to have their energy spent. Now, why such a big variation? So there were three key areas in this case. One was the occupancy requirement. So some buildings, they still had a skeleton staff that required heating and cooling. And it's also what is acceptable to those building occupiers, whether they need the building to be up at temperature for the same number of hours in the day, even though there may be 10% of the staff working in those buildings, question mark. Data visibility is another key one. So how much data can we actually extract from the BMS, and how sophisticated is the BMS to provide us with good quality data that we can use to make these fine-tuning decisions. And then the last one is what we do with the actual data. So if we have the resources and the staff to process the data, understand the data, and take data-driven actions, we can achieve far more useful outcomes than if we cannot afford to do a great deal with the data. And yeah, to wrap up, I think as engineers, so this being a CIBSE event, I assume that most of us are from engineering backgrounds. As engineers, we may think that net zero is an engineering challenge, is a technical challenge. But actually, the other side of this is the collaborative side and the communication aspect of this. So how we communicate this to people who occupy those spaces, to contractors, managing agents, and all the different parties that are involved in running the day-to-day of a building, and also the companies that occupy these spaces, the company culture, and whether their aims align with a net zero future. Yes, so challenging all of these beliefs and making sure that everyone is on following the same path, following the same journey. And then the last one is fit out. So if we have a net zero shell and core building, it doesn't necessarily mean that it's going to turn into a net zero operational building. And as we know, a lot of fit outs involve stripping out what is already there and then fitting it back with new, sometimes virgin material, which has very negative embodied carbon consequences. So just thinking more holistically is the thing that we really need to rise up to the challenge of net zero. And I think, yeah, that's it from me. So we have some time for some Q&A.
Thanks, Kasia, and thanks to all the speakers. So let's go first with the questions that we have received, and then we'll continue a little bit more with some questions for me. So I think the first one is for probably Jen. So the attendee is asking, I strongly agree with the increased temperature set point, but I wonder how designing around this can compromise future adaptability. Is it something that has been considered?
Yes, I think that there's kind of, in my mind, two sides to the adaptability question. The first is looking at actual climate change adaptability. So temperatures are changing outside, the climate's changing, and that's going to drive loads higher. To factor that into the modelling, we've actually factored in the usage of a Design Summer Year 1 high emissions 50th percentile scenario. And so that does include an allowance for climate change already within the calculation. The other side of that, though, is tenant adaptability themselves. So as business models change, tenants change, and that's a lot of what's been driving the reductions in energy within the tenancies that we've seen. So it's not necessarily an increase in energy, it's more likely to be a decrease in energy. And certainly data analysis supports that claim that tenants are reducing their energy bills, and certainly fundamentally they need to. If we as a planet are going to achieve the Paris-proof targets that we've set, we need to reduce our energy use within tenancies as well as within HVAC systems. And that's what we can see already in data analysis of new tenant fit outs.
Okay, the next question was, are CIBSE or any other bodies currently commissioning wider studies into how peak loads compare to the real operational loads of buildings to advise new design standards? Does anybody want to comment on that? Or I think the CIBSE knowledge panel is probably looking into this. And also there are the LATE pioneering projects that Jennifer may want to comment on. And their goal is probably to demonstrate that everything is doable. Do you want to say anything about that, Jen?
Yeah, no, I think you've probably covered it off quite nicely there. Certainly there are a number of projects already going for these targets and implementing them within design. And so I'm sure that we'll be able to see some good sort of data come out of those projects.
Yeah, I guess what actually we do need is to address this topic with RIBA, BISRIA, and all the other bodies to change the rule of thumbs, for example, for the very early stages, to make sure that we're not oversizing since stage 1 or stage 0, that we do keep in mind this since the beginning of the project. The other question was, if there is no stick planning or building control compliance requirements outside of London to drive a developer into producing a net zero carbon commercial development, i.e. a speculative build office which removes the feedback loop, I struggle to see how we will achieve these targets without clear legislative direction. What are the panel's thoughts on how developers can be persuaded to embrace this net zero carbon building? Anyone to comment?
I think from my perspective, the way this is, one of the things that is going to come to our help is the market-driven side of carbon offsets. So if let's say we have a building today that is not net zero and we take no action to move it towards the 70 kilowatt hours target, by 2050 as a nation we have a commitment to be net zero, and there will be pressure from the government for all organizations to operate at a net zero level or pay the penalty, and that penalty will be we foresee to be a market-driven penalty, because there are so many trees you can grow and there is so much carbon you can suck out of the atmosphere. So it will be a supply and demand type thing. We have from one side people trying to buy carbon offset credits, and from the other side market producing these offset credits. So if there is a very high demand, the price will shoot up, and economy will favor taking action to reduce loads. What I'm hoping for is that it won't be a cliff edge type thing where 2049 everyone realizes, oh, we have to offset all of this excess energy that we are producing. Certainly if there is a trajectory and a step-by-step kind of movement in that direction, I think we will see some real change.
I am aware that also Leti made a letter to Boris Johnson saying for example, reducing the VAT to 0 for refurbishments to enhance this kind of works compared to demolishing a new build, which will reduce the carbon footprint. So let's hope that Boris Johnson is listening. As the BCN stage is still developing and to be implemented, what is the best way to get or calculate the operational energy if we don't have measured data yet?
As the BCN stage is still. So I guess the best way to get measured data is to use the meters that are currently on site. So every building will have a electrical supply, and if it's got gas, it will also have a gas supply. So I guess it would be to use those, and whilst we can compare that to potentially how the building is designed to operate, and we can compare that potentially to benchmarks or rules of thumb, or you can dip into existing databases such as the Display Energy Certificate database to see how the building fares against similar buildings. If that answers your question, I think that, so what Leti sort of set out is monitoring and declaring energy consumption for 5 years post handover. And the platform they suggest you use, and this was, I think it's sort of a bit of a placeholder platform, but it's something called Carbon Buzz. So if the question is about how should we be declaring that in the meantime, whilst the BCN requirement, or whilst the BCN stage comes into effect, then there are platforms out there that you can already report energy consumption to that are useful. I mean, they're flawed in some ways, but they're still useful place to report, I guess.
And I suppose building off of that, you shouldn't underestimate the ability of simulation to improve or plug some of those data gaps in the interim as well. So obviously, when we can use operational data to feed a simulation model, we'll get the most accurate simulation model. But where there's data gaps, it's really important to look at a range of different possible plausible scenarios and really make sure that we're optimizing the building across that whole range of uncertainty. And that's, I think, where simulation can really come into its own in terms of substituting for data that maybe isn't always available at the moment.
Ollie, you were mentioning about feedback loop, and that at the moment is potentially inside the companies, that some companies are already talking to their clients and agreeing to monitor the energy consumption afterwards. Do you have any examples like?
So, I mean, we at Hawley run a number of sort of lessons learned sessions and schedules. I think they're flawed in some ways. They're not perfect, but they're what we do at the moment. They're the best we've come up with at the moment. I think for the lesson learned kind of stuff, though, it really comes into full effect if you have, say, a developer or an estate that has a number of different properties, and it is a no-brainer to sort of use the data and the lessons learned from some of the buildings they're currently already operating to inform the design of their newest, of their latest building. So we use workshops quite a lot, and they're quite a good way of doing it, and we use lessons learned schedules. But I think what would be great to see is a slightly more industry-wide approach to it, because I think if we're really going to streamline change in our industry and streamline processes that work, systems that work, systems that don't, if we're going to understand that as quickly as possible, I think the lessons learned process and the feedback process needs to capture more of the industry rather than on a company by company level.
Yeah. Another question was, should an independent commissioning agent be involved in zero carbon new and existing buildings to reduce the energy performance gap and ensure via independent testing to verify all installed equipment is being installed as per design intent?
So I mean, that's what the be seen requirement is trying to address in many ways, is to encourage people to declare or to force, I guess, in most instances, people to declare their energy consumption against how it's designed to perform. I think it's a very interesting point, though. Should there be someone specific there to make sure that at the point of handover, the building is performing as expected, rather than, I guess, finding out a year later? I'm
sorry. I'd add on that as well that, in Australia, it's, I wouldn't say routine, but it's certainly quite common, and I think more common in the UK than it is in the UK. So in Australia, I've had a lot of success with ICAs on projects, and I would say yes, seen huge benefits that way, and it's the difference between handing over a building that works or, Ollie, as you say, waiting 12 months to find out.
Yeah, I was thinking about the word independent. So obviously that would guarantee the quality of the installation, but obviously feedback needs to be given also to the designer. So imagine it's as per design, but the design is oversized. You're not actually solving the problem. So it's a mutual cooperation, probably.
And to add to that one, I think commissioning is such a complex and difficult topic that cannot be, we can't simply overcome all the issues we see with commissioning by independent testing. Certainly the independent testing will help, but I have worked on projects where the independent testing hasn't really provided enough value or made enough of a difference. One of the key things that often goes wrong with commissioning is because it's at the end of a program, and if various things get delayed during a project, commissioning is the one that usually pays the price because it's the last one, and clients need the buildings to be delivered on time because they have plans for those buildings. So commissioning is usually the one that gets squeezed, and the quality aspect of it drops. I think what really can make a difference in the commissioning side of things is if we can have tools that allow us to evaluate performance over a longer term. So instead of spot checking whether things are working fine when that commissioning person is on site, if we have tools such as a product that we are offering, so it's looking at BMS data over a similar to, I did show a slide earlier on, so looking at BMS data over perhaps a week, 2 weeks, or even months, if depending on how long the commissioning period lasts, and evaluating the way that commissioning work has been carried out over a course of time as opposed to a spot check. So I think we do need a little bit more than that, and standards like Passive House do address this very nicely through their independent measurement and verification and certification routine.
Okay, thanks. Another question was, smart optimization seems like an easy and potentially big win. Does anyone think we can expect to see any legislation to improve the existing building stock, given 80% of it will be here in 2050? John, you may want to comment on the London plan on Part L. We have been commenting on that as well.
Yeah, definitely. I think one really key thing I think is likely, hopefully, to be a game changer in the UK, the way it was in Australia, is NABERS, or the Design for Performance UK NABERS project. So in Australia, over the first 10 years, it was a voluntary scheme. So you'd volunteer to get your building rated, and that was driven by a lot of what Kasia was saying, the public pressure and visibility on buildings. But as that scheme matured, probably operated for about 10 years, and then now it's mandatory at point of sale or lease of at least 1,000 square metres of office space. So I think it's probably more likely to be a mandatory disclosure scheme rather than a mandatory performance scheme, but I definitely think it's coming.
Jen, sorry, just a question. Do you think the be seen requirement in the London plan proposal, do you think that's sort of teeing up that kind of NABERS, I don't know, the NABERS side of the value of the property being affected by its energy performance? Do you think that's part of what the be seen is trying to tee up? Yeah,
absolutely.
If I can add something there, so minimum energy standards regulations, or MEES, is still in its early days. So I think only F and G rated buildings have been affected through MEES at the moment. But as regulation tightens up, and we need to do more to, we need to address the buildings that are in the higher EPC bands. These sort of things will become more and more important, and we will see more smart optimization happening. So I think there will be multiple triggers and multiple push factors, one from the legislative side, other from just people realizing the value they can get, the savings they can get, and the benefit of data, putting aside the energy side of things. Yeah, I think all of these put together hand in hand can really make a big difference.
Thank you. There was another question. During design stage, if we follow green building code, would be sufficient enough, or any other specific precautions or guidelines we need to follow to optimize the consumptions?
Yeah, absolutely. If you haven't seen the LETI Climate Emergency Design Guide, I definitely recommend that you download it. if you review the slides at the end of the presentation, I provided a link, but it's also available at letty.london, Climate Emergency Design Guide. And that's, I suppose, 100 pages of what does best practice look like now and what might it look like over the next 10 years. Certainly, I think, you know, throughout the presentations, I think we've showed that our current design standards are not delivering what we need to deliver. They are just not. So we really, really, really do need something new. And so follow the Climate Emergency Design Guide and let's, I mean, new decade, let's keep this forward.
Yeah, and also CIBSE has commented on the LETI guidelines, and they are very much in line. So just a note on that is that obviously those are targets that shouldn't be taken outside their context. So we cannot simply say use X amount of watt per square meter for the heating if you don't provide the correct values and you don't agree this with the architect and with the client. You cannot simply work on your own. It must be a team effort. So obviously there was there are other questions. I might have missed this. Is neighbors rating system made for actual measured performance? Jen, you want to?
Yeah, absolutely. The way it works is that building owners submit annual utility invoices, as well as data about the hours of occupancy of the building, the leased area, and any after hours requests. And your neighbour's rating or neighbour's certificate is issued annually based on your measured utility data. Yes.
So I was wondering whether the panel think that maybe designing for buildings in London would be different comparing to designing for buildings outside London.
In what sense, Rosella?
In terms of targets, energy performance and everything. So obviously in London there are spatial constraints, acoustic constraints, there are a lot of additional factors that could affect the design.
Yeah, I mean, I philosophically see it that, look, we do within the UK have a finite supply of renewable energy, and I think everybody needs to do their share to bring down that energy. Now, the UKGBC have presented their climate change targets as also a Neighbours UK rating. Now, the Neighbours UK rating corrects for hours of occupancy as well as area that's in use. So that allows buildings that are operated differently to be compared against each other in a fair way. But that said, there's no correction for weather, and that's been shown to be because it's a minor factor within operation of buildings within the UK, given the climate is quite similar from sites. Sorry, rather there's a climate correction but not a weather correction year on year. And so by getting into these, I think, more richer metrics, things like neighbours ratings, rather than energy use intensities, we can go that next step and adjust for different operating parameters or different locations and different climates. But fundamentally, we do, as the UK, have a budget and we have to get there together. I think we need to just be careful about making dispensations without the data to back up where those dispensations are coming from.
And there was a question for Oli. You were mentioning there are existing databases that haven't been successful. You may want to talk a little bit more about that?
Yeah, sure. So there's a few databases that have sprung up in the past. So one of the ones I've already mentioned is Carbon Buzz. One of the ones I showed you data for is the Display Energy Certificate database. So DECs are mandatory for all public buildings over a certain size. And those databases, I mean, they're two completely different databases, but they're flawed, I guess, for different reasons. So the DEC database, as an example, is missing a huge amount of contextual information. So it tells you the energy consumption, and it tells you the sort of contribution from renewables and the floor area and that sort of stuff, but it doesn't provide any information that the sort of neighbours scheme provides, such as occupancy levels, such as head count in the building, you know, all that sort of stuff, which provides a huge amount more context, I guess. And then other databases which haven't quite been as successful, things like Carbon Buzz. Largely the reason for the reason they've not taken off is because they've been voluntary, and it's no one's priority. Historically, has been no one's priority to declare their energy consumption, because I guess most people don't really see much of a benefit from doing that. And so I think hopefully that's where the be seen requirement within the London plan will differ, is it will add extra context and will also add that mandatory requirement. So hopefully we'll definitely see more of an uptake because people will be forced to do it. But hopefully we'll see some real value in the data that database produces.
Okay, probably last question and then we can wrap up. How do we balance smart buildings and smart optimization with the abilities understanding of the end users? Honestly, it's a fair point. Anyone wants to comment on this?
Kasia?
Yeah, I think that's a very good question. I was trying to read the full question. Yes, there is always a fine balance between having smart buildings and having buildings that people can use in the way they were designed. So the more complicated we make buildings, the more training we need to provide to people to use those buildings. I think as designers, perhaps we don't always do that. So if we create complicated buildings, we need to make sure we allow and budget for the amount of training and training requirements, and also for when people move out and new people move into the buildings, we need to make sure the continuity is always there. But I think the way the industry is moving is simpler buildings, because so a lot of the passive house buildings you see, they are really basic and they work really nicely, both in terms of health and well-being side of things and the energy angle of things. So the smart optimization is about what we see in the BMS, and it's something that only a handful of people see. It's not for the end user, the tenants and so on. It's for engineers, building managers and so on. So the BMS can have the ability to take a lot of data, and we can use that data to make sure the building is running very smoothly. But controls is another subject, which is how users interact with their space, and I think that needs to be as simple as possible.
I think to add to that, I don't think smart necessarily always needs to mean complicated. So I think smart buildings can have simple control strategies, can have reasonably simple systems, but just operated in a smart manner. So for example, a smart control strategy might be the boilers only turn on if there's a demand for them. So that's reasonably straightforward. And I'm certain existing FM are used to working like that and are able to work like that. So I think there needs to be maybe a bit of a disconnect between smart and complicated, because I think we need smart buildings, but I think we also need relatively simple buildings, as Kasia said.
Yeah, and it probably depends also on the type of project. You can have a centralized system, so you take away the responsibility of the end user of using the system efficiently. It depends on case by case. I think we can wrap this up here. Thank you to all attendees, thank you to all the panelists, and thank you to the YPG members that have been helping out in the background. So see you next time, and the slides are going to be available soon on the website, and the video is going to be uploaded on the YouTube channel. Thank you all, and see you next time.